All right, so now we are doing one optimization, which is weighted quick union. So weighted quick union, the whole idea is that now we want to actually set a criteria for how we break ties. Okay, so we want the trees to be as shallow as possible to avoid the worst case linear time find spindly trees. So what we do is when we union, in other words, make the root of one tree point to the root of the other tree, we make sure that we have the smaller tree point to the larger tree. And the reason for that is because if we have a smaller tree, I'm representing trees by triangle, point to a larger tree, the height of this smaller tree is kind of absorbed into the height of the larger tree, right? We don't really notice it because it's kind of like this, right? They're kind of, the smaller tree is nested inside. Whereas if we had it the opposite way, if we had, I'm gonna draw it here, we have the larger tree pointing to the smaller tree, well, what's gonna happen? We're now gonna have this, but now we're also gonna have this, and so the height of the entire resulting tree has increased pretty significantly, and that's gonna result in our spindly tree, worst case. Okay, so that will guarantee us the maximum depth of any tree set is log n. That's a beautiful guarantee, and the proof behind that is a little bit beyond scope. If you are interested, you can look in CS 170. But basically, that's all you need to know. So in this example, we're not going to draw the array representation, same thing as previous question. But after we do union, now we need to consider which is the smaller tree and how do we make one point to the other, okay? So 0 at this point is going to hold -3. It has 3 nodes in its set. 3 is going to hold -4. So which one is smaller in terms of size? The 0 set is smaller, right? So we need to have that point to the 3. And so what's going to happen? Okay, so again, I'm going to use my reverse pointers. I'm just going to first draw the nodes. Okay. Okay. All right. And so what's the array representation for this? Well, we have 3 for 0, right? Now its parent pointer is 3. Originally it was the root, so it didn't have a parent pointer, but now it's not the root anymore. And then 1 and 2 are going to have 0. 3 is going to have now -7. It's now the root of the entire set. 4 and 5 are going to have 3, and 6 is going to have 5.